New Zealand Tech Podcast, the voice of the tech community. Proudly supported by Umbrella Connect.
Tech Podcast. Today we're talking with Stefan Powell, who is the Chief Technology Officer and co-founder at Dawn Aerospace. Welcome along, Stefan.
Yeah, thanks, Paul. Thanks for having me on the show.
Yeah, great to have you here. I know we've sort of bounced the idea of having you on the show around sort of 6-12 months ago, and things seem to be going from strength to strength with Dawn Aerospace. You've just had a big announcement in the last 24 hours. Tell us about that.
Yeah. We had Movac come on board, put some money in behind us. Really great. I mean, like they're New Zealand's biggest VC. It's epic to have them having them support us. They just bring so much experience to the team. You know, they've been involved in some of New Zealand's most successful tech stories, but as well GD1 has actually come in as well, and then a bunch of the insiders as well, like Icehouse Ventures that backed us in our seed round a couple of years ago. They've put in a good chunk with it as well. So yeah, stoked.
That's excellent. Are you able to reveal sort of how much you've raised or what sort of direction or anything like that?
No, we're keeping that pretty close for now, but it's substantially more than we've ever raised before, and it's enough to really grow the company from here. You know, we had pretty strong revenue anyway, which is a little bit weird almost as such an early space startup. You know, we were getting pretty close to almost breaking even. But, we're only working on a small part of our very big dream at the moment, and so we really want to grow from here, you know. So this money is really about supporting growth through the next 12 months and probably roughly doubling in that time.
Fantastic. So before we sort of delve in a little bit to your story and the Dawn Aerospace story, can you give a very sort of short summary of what Dawn Aerospace is working on, or at least what you're happy to reveal at this stage of your master plan?
Yeah. Well, I'll start from the very top. I mean, Dawn is a space transportation company. We take a very holistic look at that. It's about getting things to space. That's delivering things to space. It's about positioning them once they're in space. That's like satellite thrusters, allowing satellites to move around. And in the very distant future, we think that that's going to be about getting huge amounts of stuff back down to space. So you really have to address all of these three things in a way that kind of makes sense. You know, right now they're somewhat separate. So, you know, like we're working on a spaceplane to have dramatically more scalable access to space. You know, not 2 or 3 or 5 or even 10 times as much access. It's more like 100 or 1,000 times more access to space, and at a dramatically lower cost. And in terms of moving things around in space, it's getting away from these legacy propellants that people have used, like hydrazine, that were really great if you had big military budgets, not so great if you're trying to do really small satellites where, you know, the cost of dealing with the horrendous toxicity of hydrazine is just, it's prohibitive. You know, like these people are trying to build satellites for $250,000, and the cost of just dealing with hydrazine is like $500,000. So it's twice as much as the whole value of the satellite. So it just doesn't work. So that was a problem that we really needed to solve now. And we're also kind of in the back of our minds figuring out ways to build in the return capability as well. So we don't talk about that too much at the moment, but everything that we're working on has to work harmoniously with the idea that we're going to have to be able to get a huge amount of stuff back down to Earth as well pretty soon.
Oh, that's pretty interesting. Well, definitely we'll want to delve in a little bit to that and the importance of that. A little bit further in. But first up, what's your background? Where were you born? Where did you grow up? What's that backstory?
Yeah, so I mean, I'm a Kiwi. I was born in Wellington, raised in Hamilton. Did all my schooling in high school and stuff here. But I'm a dual citizen. I'm Dutch as well. And the Netherlands is a pretty fantastic place to study. So I actually went over there and actually lived in Germany for a couple of years and taught English in kindergartens of all places. Then I kind of decided I wasn't going to be an English teacher. So I wanted to go do engineering, and the TU Delft was an excellent engineering university in the Netherlands. I didn't really know it at the time that they had these fantastic rocket programs, but I really wanted to get into sustainable engineering. So you might think, well, I ended up building rockets, so it's kind of a little bit polar opposites, but I'd like to think that these two things are kind of coming back together now. I'm really trying to pull sustainability and long-term thinking into what is probably the most unsustainable industry that currently operates. It's just horrendous waste in the aerospace industry in general. So we really need to change our thinking on that. So that's where I met the majority of the founders, with the exception of my brother, who I obviously met a little bit earlier.
Glad to hear it.
Yeah, exactly. But that was where a lot of the really like core rocket science expertise came out of. That was out of Delft, out of these really cool student rocket programs. That was 50 odd people. We got together. We figured we wanted to do something cool as part of our, actually extracurricular. It was on top of our studies. So many awesome minds together. You could do really cool stuff. We ended up working on these big hybrid rocket motors at the time, which are a slightly different type of rocket motor again. But we could run this project entirely ourselves. It was kind of this almost like business boot camp where the outcome didn't really matter because you were students. But we had to go raise our own money. We had to go convince these other companies to give us machining time or fancy materials or let us use their 3D printers or all this weird stuff, because we're always out for weird gear. You always just need weird materials with when you're building rockets. So it let us form this team and really form almost like a pseudo business. We weren't trying to make money, but we were trying to break a European record at the time. We were trying to do some world firsts. So we ended up building this pretty huge hybrid rocket motor. Actually, is about 1.5 ton of thrust, and we put that on a rocket that was about 200 odd kilograms, and we flew that from a military base in the south of Spain. We convinced the space that we could launch this huge student-built rocket there, which, looking back, amazes me that we actually got that through. And it took us a couple of years to get it right. We went down there, tried to launch it, just had so many issues with it. We ended up having to go back to the Netherlands and completely rebuild the rocket and come back the next year and launch it again. So we had, that was an example of one sort of failure that we had that really, let us develop our skills, let us learn a lot about engineering, about what works and what doesn't, and how to build an epic team was probably the main thing, actually. The last bit of that project was actually launching the rocket, and it flew to, about 22 kilometers altitude and Mach 2.5, and it was really cool, but it was kind of all over in 90 seconds, and it was like, wow, it was like this 5-year program with 50 people to build this rocket. And then it was all over, and we thought, well, that was cool, but there's got to be a better way. And that was really when I started talking more to my brother about this stuff. And he had a long history in helicopter modifications back in New Zealand. He'd been working locally here, really successful local companies developing really cool technology and then exporting that to the world, hugely lucrative. And we kind of put our heads together and we thought, well, there's no reason that we can't take these high-performance rockets and build it into an aircraft, get that operational flexibility and usability of an aircraft. Why can't we build a rocket that you can fly twice in a day? And so that was when we really formed Dawn as we know it today, us 5 founders, including my brother.
When was that? What year was that?
That was sort of late 2017.
Yeah, okay.
So then through...
And how long was that on from when you finished studying?
Yeah, that was about a year and a bit after I finished studying. It's when I say it now, it sounds so clear cut, but it was a transition. Things kind of started moving. We all had other jobs at the time. You start chipping away at it, thinking about it, kicking ideas around.
Yeah.
We ended up buying a small model aircraft airframe and designing the rocket to go on the back of it and show that, hey, we can fly, a small rocket plane many times in a day. There's nothing fundamentally silly about rockets that mean you can't use them multiple times a day if you just design it right from the ground up. So we did that. Yeah,
that's cool. So in between studying and what is now Dawn Aerospace, you did a little bit of work out in the aerospace sector. Tell us a little bit about
Yes.
things.
So I worked for a company called Hyperion Technologies. They were a satellite component manufacturer, so they kind of make what they'd call attitude determination and control systems, which for anyone else out there is basically the if you like, the eyes of the satellite. It tells the satellite where it is and what direction it's pointing in, its attitude. And then the control part of that is, once the satellite knows what orientation it's in, it might want to change its orientation. So there's these things called reaction wheels on them, which are basically just flywheels that are spinning. You spin the flywheel faster clockwise and your satellite will spin counterclockwise, So it's just 3 of those to control the 3 axes. So they built these systems, which are great for controlling these small satellites as the small satellite revolution was happening. But they quickly realized, hey, we can tell these satellites, or build the systems that tell the satellite which way it's looking, and then we can control that direction. The next thing is they might want to move in that direction. So, hey, let's go into building rocket motor systems for these satellites as well. And so my master thesis was actually on miniaturizing these otherwise huge rocket engines I'd been working on to bring them down to these small satellites, which was actually a real challenge. That was it was a real hole in the market because nobody had figured out how to bring high-performance rocket engines down to, like a shoebox size thing. Rather, the whole satellite's a shoebox. The rocket motor itself ended up being about as big as my thumb. So it was a real challenge, but that was kind of where some of that technology started, and now that's kind of been spun out into Dawn as well. That we've taken on that challenge, and we still work with Hyperion Technologies on some of these systems. Fantastic.
Now, it seems to me, as I'm starting to learn more and more about the aerospace and the new space sector, that there's a lot of little firms doing these really, really niche jobs. And I heard a figure the other day that there's probably 150 companies in New Zealand working in the aerospace sector, which I don't think most people would be aware of. Most of those are definitely at the sort of smaller end, and then you've got some that are multinationals that have obviously have some form of operations here as well. So there's really a lot to do and a lot going on, isn't there?
Yeah, and I think that just speaks to the opportunity and the diversity of space as well. There's just, like space is this amazing vantage point, right? If you're in one of these orbits, a polar orbit, you can at some point see or service or hear or something about every position on Earth. You'll fly over everybody at some point. So the real question is, okay, well, what can you do with that? And the answer is so many things. So many things you never thought that would be useful. And that's what these companies are working on. It's just like almost an infinite number of niches that you could carve out of that epic capability. And we're really only just at the start of realizing what that is. In that way, it's so similar to the internet in the 90s. It was like, oh man, there's this epic capability. What are we going to do with it? And that's what people are figuring out right now.
When you look at it, what are the things that come to mind for you that maybe we haven't yet touched, but are maybe coming up in the years ahead?
I certainly don't have any amazing insight. I feel like all of these things are in some crazy deep dark niche that you never thought was actually that interesting, or you'd like, how would it apply to space? But it ends up being like biology stuff of some particular biological things that grow completely differently in microgravity, and and the end result of that is you're able to produce ibuprofen that's like 1,000 times as strong as regular ibuprofen, but it's still just ibuprofen. It's not addictive like opiates or something. So that's mega for the drugs industry. Similar thing, slightly different vibe.
Was that a real world example, or just
yeah? There's okay. People working on this. I didn't dream that up.
Wow.
I couldn't dream this stuff up. I wish I could. I'd be a millionaire if I could. The same is true for super materials, being able to grow single crystal huge metals. They have crazy different properties. And you're able to do that in space. Space is an absolutely amazing place to manufacture stuff because it's so clean and there's no gravity and there's almost infinite power available to you because the sun's shining the whole time and much brighter. And there's there's just so many good things about space, and that's just in manufacturing.
Right. Now I'm starting to join up the dots on the importance of bringing things back and not just sending satellites up.
Yep.
Gotcha.
Exactly. I mean, like the things that we're doing now are the ones that are just so blatantly obvious, like low-hanging fruit, like communications and Earth observation is like, yeah, duh. Like that's amazing. And we're barely even scratching the potential of those industries.
Wow. So yeah, a lot of interesting times ahead. So tell us a little bit about what it's like to actually start your own business. In your case, what did that look like? Because it's not just, when I started my business, one person, it's a very easy process. Business starts. There's enough work coming in. That I don't need to look outside for funding and so on. But you've got multiple partners, you're entering into something with a lot of unknown around it, and it's not a particularly cheap area to be working in, right?
No, unfortunately not. It's pretty capital intensive. I think the first thing is to really have a dream. It's to really understand what you're talking about as best as you can, and understand what the end goal is, and make that end goal as really as ambitious as you can reasonably make it. Now that's good because that's the end point. You want that to be epic and inspiring. But then, the tricky bit is planning out the roadmap to actually get there. Because unless you're Elon Musk and you have, at the time for him, $100 million sitting in his back pocket, it's pretty hard to just go start a big space company. You have to be able to start somewhere, and that'll be at, whoever you can convince to work with you. So for me, that was about 5 of us at the time. That was the start. You could do that with nothing or, whatever resources we had. And then you got to figure out what can you do at that point to convince the next person that, hey, you guys are not, you're not fools. You can build something that's really amazing, that creates value, and that demonstrates that you're on the path to this amazing vision. And you need to figure out how you're going to do that at each inflection point of the company, at one person when it's just yourself, at 10 people, at 100, at 1,000, and so on. You need to demonstrate value all the way along that. And that's what I think we've done reasonably well so far at Dawn. We've found a way in. We've found a way to get real revenue into the company, to be doing real things. We have hardware in space. We're not just infinitely tinkering in the back of a shed, hoping to have something amazing in 10 years' time. We're doing real things now. Okay, they're certainly not as amazing as many other companies that have billions of dollars to throw at the problem, but it's real, and that's the key for now.
And so this is where you've got different areas to your business, the 3 areas that you talked about.
Yep.
So you're able to right now go and get real world experience, generate real dollars, whilst in the background working on some of those bigger problems.
Yeah, exactly. And like I said before, in some ways they seem like they're very different things. A space plane and satellite thrusters, what do they have to do with one another? But they all play into that end goal of having a really holistic, well thought out, and elegant space transportation system, because it's not just enough to go to space, it's not just enough to design a system that moves around in space, and it's not just enough to design things that come back. If you do it all in one thought, then you come up with a system that's just dramatically better, because it considers, mobility of things going to space at all times.
That's interesting. And do you think from what you've seen, there are many companies with that sort of holistic viewpoint, or does it seem as mostly more splintered in terms of how things have been done, certainly to date?
Reasonably splintered, but then I'd also forgive a lot of companies for not coming out with all of their, not being so open about it to start with. I think is pretty typical. We like to be pretty open about it because I'd like to think I'm actually not worried about competition. I really don't mind if people steal my ideas if they think my idea is great. I'd really just want it to happen. Our fear at Dawn is that nobody figures out this stuff and we don't get this massive opportunity of space. So we just really want it to happen. So we're very open about it. But I'm sure other companies realize this to some extent, and there are other companies that do think about it. Firefly, for example, they're building pretty classic rockets. They're essentially the same as SpaceX or Rocket Lab, but they do have pictures of space planes on their website. They're not working on them yet. I don't know why. They really should be, if you ask me. But a space plane is not a super new idea. And neither is this in-space transportation stuff. I just really wish people would start thinking about it in a much more end-to-end solution, a much more integrated thing.
Yeah. Now, when we look at those companies they're really innovating in particular areas versus, say, bigger, more established firms, and not just in space. I'm sort of talking quite generally. Very common for there to be acquisitions, right? All sorts of companies all coming together, and the bigger companies often really struggle with pushing through into new things.
Mm-hmm.
Do you think it's important for Dawn to have sort of independence, or can you see a time where you'd be open to sort of joining with other people, putting the monetary thing sort of aside in terms of actually getting the outcomes that you're looking for?
I certainly wouldn't rule it out, but we're a long way away from that sort of discussion. Sure, there's definitely ways that you can make mergers and acquisitions work. There are definitely examples where larger companies have acquired smaller companies, and they haven't really just squished them or ruined their ideas or whatever. Scaled Composites is a really good example of this. They're still an epic company, and they've been owned by a larger aerospace company for like 20 years now or something. But they're let to do their thing. They're treated as sort of like a skunkworks part of that organization where, okay, this is where the crazy out there ideas go, and we make sure that they have funding, and they do some other work on the side for us, to bring that innovation into the bigger company. But otherwise, let skunkworks be skunkworks and do their thing and create amazing innovation. So, hypothetically, I don't think we'd be against a setup like that. It also brings a huge amount of resource and capability and knowledge. These big organizations are successful for a reason.
Mm. So delving into the journey that you've had so far, you've had to go out and raise funds how many times now?
We've had our seed round. We had a small bridge round last year, and this is another convertible note. So 3 major funding rounds, I suppose.
Yeah. And in terms of how that's played out, in terms of access to expertise as well as access to funds, how's that from your perspective? Because I guess we've seen Peter Beck, for instance, was sort of very vocal in terms of very hard to raise funds in New Zealand. Certainly when he was really trying to raise funds initially. I'm certainly hearing different sort of noises today in terms of how easy it is to get access to capital, but that obviously varies from one sector to or one area to another. And then there's the access to partners that bring certain special things to the table that you might need to tap into beyond the capital.
Yep. Yeah, I mean, raising money at the moment is we were super fortunate to have quite a few options available to us, and our round was actually quite oversubscribed in the end as well. We ended up having to say no to a few people too. So I wouldn't say we've had trouble finding capital, but it's always a question on what terms you can do that. I think the investment landscape has changed quite a lot over the last 5 years, certainly, especially for aerospace startups in New Zealand. I mean, kudos to Rocket Lab in that sense. They really showed that Kiwis can do it. I'm pretty sure Peter Beck tells some stories about, being told, no, a rocket company will never happen in New Zealand. So in that sense, we have a lot to be thankful for. But no, I mean, raising capital is not it's not impossible at the moment at all. It's pretty doable. It's more challenging not being able to travel to the States. That's certainly where a lot of the capital is. But in this case, we were super happy to be able to raise in New Zealand and stay a bit more New Zealand-centric this time. You know, we had some capital come out of Europe and the States as well in our seed round. That was really great for bringing in some experience. You know, we had our investor director is Eric Swan, who is a very successful entrepreneur in his own right. You know, he's had he started companies from nothing and had billion-dollar exits, and is still very involved in those companies. And he just brings an absolute wealth of knowledge and sanity to what otherwise can be a pretty insane situation. You know, especially at least speaking for myself, I never thought I'd be in this situation. I certainly never trained for it, and I'm pretty green. So he brings a lot of wisdom, a lot of just confidence to the team. I think that that we're on the right track, and that as crazy as things are, we're going in the right direction.
Yeah. Now, if you look at where you are and what you're able to do today, would it have been possible 10, 15 years ago? You know, how much is the technology that's available at our fingertips sort of facilitating what you're working on?
The technology is definitely one element of it, like, you know, computer simulation, more advanced electronics, 3D printing. You know, there's all kinds of technologies that are helping. I would say the change in the market is the bigger thing, though. You know, like I talked about before, this roadmap is really key. Building a space plane is even more expensive than building a regular rocket. And part of the reason I think the space shuttle wasn't that successful is because they had to bite off so much in one chunk. You know, they had to build a space plane that was capable of taking 20 tons to orbit. The small satellite market has completely changed that. You know, if you could get 20 kilograms to orbit with a space plane, that'd be epic. That'd be great. You know, so the problem is literally 1,000 times smaller now. So that entry point on the roadmap of like, hey, we want to build a space plane, it's got to be able to take something to orbit. What's that something? It's 1,000 times smaller now. So, you know, it is quite conceivable that we could go raise somewhere between 100, 200 million bucks and go build, you know, a two-stage to orbit version of the space shuttle, essentially.
Yeah, wow. Now, you talked about when you were studying and learning to build a team and so on at that stage. What were the key learnings that came out of that time for you from that perspective of you know, team building, leadership, and so on?
Oh, I mean, the first thing that always comes to mind there is how to deal with failure. You know, we had so much stuff go wrong, whether it was small rockets or big rockets. We blew up so many of them, and you know, you really knuckle down. You look at the data and you think, oh, you know, why did this thing fail? And you think you have an answer, and then you go and put another engine together and you put it on the test stand, and it does exactly the same thing. Bang. And I think we did this at some point about 4 or 5 times, and we only had money left for about another 2 burns of this engine before we had to go to Spain and actually try fly it. And it was hard because we really didn't know what was going wrong. We didn't have 50 years of experience in the team or something. You know, we were a bunch of master students at the time trying to figure out why these damn hybrid rocket motors keep blowing up on us. But it really made us rally. It made us really think critically, really test your own hypotheses, and be really self-critical. And sometimes that's really hard. You know, sometimes you really have a bias towards just thinking that you're right. But really testing that, and forming a team that actually breeds this culture as well, where you have some people who are trying to figure stuff out, and you have other people that are trying to play devil's advocate and focus that innovation into the right direction, so that you actually really test your ideas before you go out and build them and test them for real.
Yep.
So that, you know, dealing with failure, not getting demotivated, being self-critical, being able to press on, find the actual solution and test it and show it, and then go fly.
Yeah.
Yep.
And how does that play out today? What does your team look like? who else is on the team, and how many people have you got, and so on?
So all the original founders are there. We've built that team. A few people that we worked with in this large student team, like we kind of cherry-picked the best ones of them as well, and they were some of the early employees in Dawn. But other than that, we've been pretty intentional about trying to get people with other expertises, other experiences. We didn't just want to build a team based on people from Canterbury University, where James came from, and Delft University of Technology, where I and a bunch of the other founders came from, because it would be a bit two-dimensional. So we've tried to draw on other people that have had other experiences, other parts of industry, other expertise as well. Get a bit of diversity in there certainly helps.
Yep. Are you able to share how many people you're at this stage?
Yeah, we're about 43 or something.
Yeah.
Growing pretty quickly. I think we have about 10 jobs up at the moment, which, by the way, we really, really want more people. So if there's anyone listening that's keen, go check out our careers page.
Excellent. Well, that was kind of what I was keen to get into as learning, what's Canterbury, what's New Zealand like to run this type of aerospace business from, and how hard is it to get the people? Because I'm sort of really curious about this broader picture, which maybe we'll head into next, around how we make sure that New Zealand really takes advantage of our current position within the aerospace sector and maximises that going forward. But what's the sort of current state from your perspective?
New Zealand's a pretty fantastic place to do really innovative stuff, really figure out really difficult new problems. We don't have a whole lot of history, especially in aerospace, so we don't have a lot of baggage with us. There's not many people here who would tell you can't do something.
Can't do that. I tried that, 30 years ago, so it's not possible.
Yeah, exactly. But the flip side of that is we also don't have someone with 50 years experience in building rocket motors here. So sometimes experience is pretty great, and Europe's pretty good for that. So we like to think we have both angles there. When we need really deep technical knowledge, or like institutional skills, or even just some hardware and testing equipment and stuff that is just horrendously expensive, like supersonic or transonic wind tunnels for large vehicles. It's like that doesn't exist in New Zealand. But it was literally across the road from our offices in the Netherlands. So we could build all these models and draw on all these experts that have been working in hypersonic aerodynamics for 20 years. We could just go talk to them about building this vehicle, and they're super forthcoming with information. They loved it. They loved that people were trying to do something really hard and innovative, because they don't see that all that much over there. But we're doing a ton of it over here. And so we could bring these two worlds together of really deep technical knowledge and capability in Europe, and a real go out there and do stuff type attitude in New Zealand. So that's, in a nutshell, I think that's what New Zealand really brings to the aerospace game, is an attitude of we can do stuff, we can go out there and build things, we can be innovative, and that's not just the people coming out of university. That's even our Civil Aviation Authority has that attitude compared to the FAA, for example. That's why companies like Wisk are in New Zealand testing their flying taxis, because CAA is super approachable. They're really keen to see how innovative technologies can work in the real world, and how to actually make them work with other airspace users, for example. So we can be super innovative down here, super fast.
Yeah, that's great. And talking of Wisk, and we've chatted with Anna Komnick in the past.
Fantastic human, by the way.
Absolutely. But you're in this sort of space area now, where there's a lot of, there's really a growing sector in New Zealand. So what sort of challenges does that create in terms of looking for talent? Because,
we're all competing for the same excellent people.
It's not just you saying, hey, come work for Dawn Aerospace. It's, there's a burgeoning sector here. And certainly over the last 12 months, even more, challenging than usual, I'm sure, in some regards. Have you seen any New Zealanders that have come home from other parts of the world during COVID that have you've been able to attract?
Yeah, well, I mean, like definitely our a big resource for us is New Zealanders who are overseas and had epic experience overseas. Be it, like we have a guy, Kiwi, worked at SpaceX. That was a no-brainer. Definitely going to hire that guy. So it's not just poaching people in New Zealand. I'm not going to Whisk and trying to pull all their good engineers, because the fraction of good Kiwis working in aerospace companies and that are in New Zealand is quite small compared to the good Kiwis working in aerospace that are overseas. Is actually that's a much bigger pool anyway.
Yes.
So there's not. I don't think there's been a whole lot of trying to steal the local ones or something like that. It's there's plenty to go around.
Yeah.
I think there's actually a lot of merit in just cross-pollination, actually, in different approaches, different expertises, different advantages that we actually end up sharing somewhat.
Cool. So what do you think we need to be doing as a country? This is an area I've been starting to speak about in the media recently, that look, we're off to this great start. Probably most Kiwis don't have much visibility of what we have as an aerospace sector. Rocket Lab has gained a huge amount of attention and well deserved. But behind the scenes seems there's well over 100 companies in New Zealand that are active in the aerospace sector, such as Dawn Aerospace, such as Whisk, but a whole lot of others in lots of sort of niche areas. But it's not something that probably most that are going through their schooling and their education have at the front of their mind, that they possibly would have an opportunity of being able to work in the broader aerospace area or new space as a possibility. So there's that side. There's obviously making sure we keep the funding channels and government sort of support flowing through. What are the things on your mind from that perspective?
Just that space is a huge opportunity, and it's getting more and more obvious all the time. The number of satellites in orbit currently is something like 4,000. I think 1,000 of them were launched in the last 18 months or so by SpaceX. By 2030, I think it's projected to be 49 or 50,000 or something. It's more than a 10x increase in 9 years' time. The growth is phenomenal. And so, like I said before, that this huge number of companies coming out of the woodwork to use this opportunity is indicative of it. And New Zealand stands to gain hugely from that. So like I said before, we're super innovative. We're really good at these random niches. I think Paul Callahan said, New Zealand is really good at niches, but we don't actually know which niches it'll end up being. It just happens to be whatever we're good at. Like Fisher & Paykel Healthcare, who could have predicted that would have been a fantastic niche for New Zealand. But productivity-wise, they're an amazing company for the country. They pull in a huge amount of cash, particularly compared to how many people actually work there. We need more companies like that, and space could really offer that for New Zealand. It's very high value. It would really help to build the middle class in New Zealand. I personally think tech is probably one of the best things for New Zealand to be putting money into, if we have money to put into the economy.
100%. Yeah. Well, the productivity, sort of the return, per person that gets generated, back into the economy, and what those individuals are able to earn when we look at tech, we look at aerospace is pretty solid, right?
Yeah, exactly. Jobs into the upwards of 80K is obviously very common, and it goes. I think the average of a company like Facebook is more like $200,000 is the average wage at a company like that. We need more companies like that bring in that sort of value to the country in New Zealand. And space is great because it's one that is pretty location agnostic. It's kind of per definition like an international industry. If you're working in space, the thing you're building or servicing or whatever, even downstream data product or whatever, is probably an international thing because the data is international, the service is international. So it's very easy to export to the rest of the world, even if we're stuck in the middle of the Pacific Ocean down here.
Yeah. Well, I think it's a pretty fantastic place to be. Well, it's been really, really interesting. So, just sort of, I guess the question is, where to from here? What's next for Dawn Aerospace? What do you think your next big mountains to climb are, or whatever the space version of that is?
Well, I mean, the last 6 months have been pretty big for us in terms of getting hardware in space and showing that our satellite thrusters actually work. We had the first firing of our B-20 thrusters, which was a new propellant combination that had never been flown in space before. They were, the green propulsion. They don't use this nasty chemical hydrazine anymore, so there's this really fantastic option for satellite builders to use. And so we're seeing a huge uptick in interest of that because it's been proven in space now, great, it's low enough risk that all of the early adopters want to move in on it. So the real hard thing for us now is actually just satisfying that demand, is figuring out how to build enough of these systems for all the different satellite manufacturers out there that want to jump in on it. It's a real challenge. But
it seems like a good problem to to have.
Yeah, would like to call it a success problem, but it is also a genuine problem because the space community is small, and if we don't execute on that, they'll quickly realize hey, maybe we shouldn't have done that. Maybe we'll go back to the old stuff, which we don't want because there's a huge advantage here, and that's just the first step. The next step after that is really building full propulsion systems, and after that there's a whole lot more to come before we actually integrate that into our launch vehicles. And of course, that on the launch vehicle side of things, the next step is to start flying our Mark II, show that can actually fly to space twice in a day. And once we've done that, that'll be a world first. Humanity's never gotten anything above the Kármán line, 100 k's altitude, twice in a day. So that would really be, in our eyes, the start of a revolution, the start of truly reusable, in the same way that you think of an aircraft as being reusable space hardware. And then we need to scale it up and build a real product that can actually get stuff to space and get stuff to orbit.
Now, I'm just curious, and I'm sure there are others that aren't deep experts on the stuff, but they're curious about that Kármán line, that 100 kilometres up. That's what, not Virgin Orbit, the other one,
Virgin Galactic.
Yep. Because Virgin Orbit are out building space planes, right?
Exactly.
But
Virgin Orbit are building rockets, vertical
that's
rockets.
Right.
Yep. Virgin Galactic are building space planes.
That's right. Getting my things mixed up. But with so with their space plane, they're aiming to, or they're going to that kind of 100 kilometre type mark as well. Is that?
Just slightly less. That's slightly lower performance than like the first stage of a rocket. So what we're aiming for is that our Mark II Aurora and then the first stage of the Mark III will really be the same performance as the first stage of a rocket. So if you've seen like a Falcon 9 launch, that first stage generally goes to sort of 100, 120, maybe 140 kilometers altitude.
Right.
And it does this big ballistic trajectory. And then it falls back down into the ocean.
Yeah.
And then, they use their rocket engines to slow down so they don't smash into the atmosphere too hard. And then their rocket motors to actually land on a barge in the middle of the ocean.
Yep.
So that's a great way to get your rocket stage back. We want to show that we can do that exact same profile with essentially a space plane, but instead of needing propulsive force to slow down and then land, we can save the fuel, instead have wings and landing gear, and be able to turn around and glide back to where we took off from. And that has all kinds of other advantages, like we're not reliant on engines for landing. Wings are generally much more reliable because they're static. They're there. You don't have to turn them on.
Yep.
You have all kinds of safe abort on the way up. If you had an issue with your engine, you'd just be able to turn around and land again. You have all the all the amazing usefulness of an aircraft, that it's certified under aviation law, that it can fly out of basically any airport. You bring rockets into this aviation model, you fly it like an airline flies multiple times a day, because why not?
Yeah, right. Yeah, that sounds pretty good. And where's the entry back into the atmosphere? What point is that at?
Yeah, I mean, it's not like a hard line.
Yeah, okay.
It just gets the further down you go, the thicker the soup gets, and the faster you're going too, because you're falling further now. So for a rocket that doesn't have any wings, that's a real problem. They really sort of hit the wall, is what they say. But if you have wings, you're able to generate lift, and you're able to start slowing your descent, so you can pull up. And what you actually do is you do that in the really high atmosphere, sort of at 25, almost 30 k's altitude, and then you actually go back up, so that you scrub all your speed off in the higher atmosphere where it's really thin, and you just don't get as hot, you don't see nearly as many forces, you don't need as much in terms of thermal protection systems or fancy materials or anything, because you get rid of all of your energy before you've fallen down into that thick soup where the atmosphere really burns you up.
So how different is that to the space shuttle? Because I remember, their heat issues with the tiles, and haven't seen the space shuttle, and NASA. It's
so the space shuttle's coming back from orbit.
Yeah.
So that's doing 28,000 kilometers an hour when it comes back.
Yeah.
Luckily, we'll only be doing something in the order of 2.5 or 3,000 kilometers an hour when we hit the atmosphere. So it's fast, but it's 1/10 as fast, and the heating rate happens to be a function of the cube of your speed. So if we're doing 1/10 the speed, we have 1,000th the heating. So the space shuttle needed pretty fancy thermal protection systems to be able to survive, just like any capsule does. Yep. We almost need nothing. Like Virgin Galactic's aircraft almost has no thermal protection system at all. I think it just has a stainless steel cap on the leading edge. That's all you need.
Wow. So it's just completely different.
Yep. And you can, just being able to do that means you recover 95% of your hardware. So there'll still be a second stage on board that, goes off to orbit, that brings the satellite into its orbit, and we'll lose that. That's expendable for now. We have ways or plans to be able to recover that in future, which makes the full system reusable, and that's kind of the holy grail, if you like. But for now, we're shooting for sort of 95% reusability, which is a pretty, it's a good start at least.
Yeah. And with your first generation, tell us just a quick on where you got to with that, and then what you're doing with the second generation.
Yeah. So the Mark II, which is the first. It's the technology demonstrator for the real deal. So it's the smallest version of this plane that we could build that's still going to fly the same trajectory. It's still going to be able to get to, above 100 kilometers altitude in a day. Right. So we have the first prototype of that vehicle. We'll be able to fly. We have a very build-up sort of test scheme. It's not like flying a regular rocket where, you build it for 5 years and you stick it on the pad and you light the candle and hope that it works. This is an aircraft development. It's very iterative. It's very built up. So, the first thing you do is a bunch of taxi tests. You drive it faster and faster down the runway, and then eventually you take off and you fly a few circuits and you come and land. And actually, before we even put a rocket motor on it, we fly it on jets, because jets are commercially available, they're cheap, they fly very well in the atmosphere, and that just lets us learn about the airframe, learn about the avionics, make that not quite so experimental anymore. And then we put the rocket motor on that. So we'll start flying in probably the next few months or so. We don't really announce dates, because this is research and development. You never really know how long it's going to take. And then after that, we'll put the rocket motor on it. But the rocket motor is already in pretty late stages of development. We're doing a lot of testing on that, and things are going pretty well. So we're pretty confident that at some point in the next year or so, we'll have a real rocket plane.
That's very cool. That's excellent. Anything else you'd like to add, Stefan?
No, it's been great.
Fantastic. I really, really appreciate you taking the time to drop by. Very, very interested to follow the rest of your journey, and I'll certainly looking forward to having a closer look at what you're doing. So it'd be great to see what's happening down there in Christchurch at some stage. So
we'll have to have another catch up in a few months' time once we're flying.
Yeah, that's great. All right, well, all the best, and I think let's hope that we can really keep things moving as far as the New Zealand aerospace sector goes as well. But I think a lot of people are very, very excited about what you're doing, and wish you all the best for the next steps.
Yeah, thanks. We're super stoked and excited about it too.
Good stuff. All right. Well, thanks everyone for joining us here on the New Zealand Tech Podcast and the New Zealand Business Podcast. This is, I guess we've sort of delved into a bit of business and a bit of tech, so we'll be sharing this out. So whichever of those you're subscribed to, or if you're subscribed to both, then you probably won't have too much chance of missing out on catching this. If you've picked this up on one of the live stream videos, then you'll be able to find the full podcast to listen to in your earbuds through whatever your favourite podcast app is, whether that's sort of Apple Podcasts or Google Podcasts, Spotify, etc. So, thanks for joining us. A big thank you to our show partners as well. Really appreciated to have Umbrella Connect, Vocus, Vodafone, Spark, HP, Datacom, and Palo Alto Networks on board supporting us at the moment. So, great thanks to them. And thanks again, Stefan.
Yeah, thanks for having me.
All right. Cheers.
New Zealand Tech Podcast, the voice of the tech community, proudly supported by Umbrella Connect.